Hello, Precalculus student. This video is for chapter 3.1, still complex number part 3. So we will look at when this complex number show up when we do a equation, when we solve quadratic equation. So instead of saying that no solution, whenever we're doing a square root of a negative one, we would write it as a complex number. Now, in these equations, you will see that there are cases where there's no complex number. They're all real, okay. But it is also a good idea to review all the factoring techniques and all the solve quadratic equation techniques before we go into 3.2 with quadratic function, and also later on when we do polynomial function. So the first is factoring. So when we solve a quadratic equation, the most simplest way, or the first thing you always want to try is by factoring. So there are a few factoring methods: diamond method, grouping, and difference of square method. So this is a different square, right? This is a square. 49 is 7 square. So you can write it as x squared minus 7 square. And we know that these are the result of two conjugates. So what are the original conjugates? The conjugates are x minus 7, x plus 7, right? So long as you can write it as a difference of two square, you can factor its conjugate. And then you split it as solve means you want to x equal, right? X equal to 7, x equal to negative 7. Of course, you can also do square root, but if it is a square number, you can just factor. So the second is you don't see square difference of square anymore. You see a trinomial. So you should always check the diamond method for factoring. So we have B here and C. A is 1. A is equal to 1. So AC is 12, right? And then B is negative 7. But notice if A is 1, you just do diamond. Okay, so think of two numbers. When they multiply, they are 12. When they add, they're negative 7. Of course, 3 times 4, right? Oh, but when you add them, they're not negative 7 unless you do negative and negative, right? So when you multiply these two, it's 12. When you add them, they're negative 7. So because A is equal to 1, you can just factor it directly using the number. X minus 3, x minus 4 equal to 0, and you split them. X minus 3 equal to 0, x equal to 3. Split them into 2. X minus 4 equal to 0, x is equal to 4. So this is the regular diamond because A equal to 1. Now, when A is not equal to 1, you have to do AC diamond and grouping. Okay, what you do is you do AC. AC. A times C is negative 2. B is negative 1, right? Negative 1. What two numbers, when they multiply, they are negative 2. When they add, they are negative 1. It's 2, 1. If I do negative 2 times 1, I get negative 2. If I add them, I get negative 1. But these are not like the regular one that you use for factoring. These are for grouping. So you do 2x squared minus 2x plus 1x, right? Because this is negative 2 and 1 minus 1. So you have to do an extra step for grouping if A is not 1. So the common factor for these two groups, the first group is 2x. And then you factor out 2x is x minus 1. The second one doesn't have any common factor, so 1 is the common factor, x minus 1. Right? So both of them has x minus 1, so become 2x plus 1 times x minus 1. We finish factoring. We can split into 2. 2x plus 1 equal to 0. X is equal to negative 1/2. Right? I jump some step. X minus 1 equal to 0. X is equal to 1. But we don't have any complex number because we never need to do any square root. This is factoring, but it is very common for a quadratic equation. The second method that we solve quadratic equation is called square root method. So where you only have a square or a square term, like in example 1, x squared minus x equal to 0. So you would isolate the square term on one side, x squared plus 6, right? Equal to 6. So can I take square root of 6? Yes, I can because it's positive. So I don't need I don't need a complex number. So that's the answer. You have two irrational number. Let's look at this. If I do minus 80, it's because I need to isolate the square term, right? So this square term can if there is only 1, you would not FOIL out, you would just isolate it. So it's negative 80. Oh, I can do square root now, but I would be doing a square root of a negative number, right? So square root of a negative number, so I can use whatever that I have learned for complex number and write it as a 80i, right? So that is because that is equal to 80 times negative 1, square root of negative 1. And so I simplify it. Okay, let's go down a little bit. Oh, not much space. Square root of 80 become, so x equal to plus 3 on both sides, will equal to 3. Oh, I have to plus and minus. I forgot the plus and minus. Plus and minus, root 80 is 4 root 5 because 80 is 16 times 5, right? I. So this is the answer. 3 plus 4 would 5i, 3 minus 4 would 5i. So the answer is a complex number if we allow us to do square root of a negative number. So it shows up in this question in a complex number, not in the last one. What about if I solve quadratic equation by quadratic formula? To solve it, we move everything to one side and look at all the coefficient of x squared, x, and the constant term. It become ABC. Then x is negative b plus and minus square root of b squared minus 4ac all over 2a. Right? That's simplified. So let's say this one, it is not factorable because no number can factorize 25 or multiplies 25 and add to 6. So, and it's not a square term, so we would do quadratic formula. A is 1, B is 6, C is 25, all plus, right? X is equal to negative B, negative 6, plus and minus B squared is 36, minus 4, A is 1, C is 25, all over 2A, all over 2. So that would be negative 6 plus and minus square root of negative 64 because minus 100 is below 36 over 2. So early on, before we learn complex number, we'll say no solution, but now we can. Square root of 64, negative 64 is 8i, right? Because this would equal to square root of 64 and square root of negative 1, right? That is equal to I. So we just write this and divide by 2, and you can split it, become negative 3 plus and minus 4i. Remember to divide both sides, okay? Not just one. That's the answer. Okay. The second one, let's do quadratic formula, but we cannot do ABC this way. We have to move everything to one side, plus 2. So it'll be x squared plus 2x plus 2 equal to 0. A is 1, B is 2, C is 2. This is not factorable, so x would equal to negative 2 plus and minus b squared is 2 squared minus 4 times 2 times 1 AC, right? All over 2 times 1 is 2. So 2 squared minus 8 is negative 4 over 2. So, but negative 4 is 2i, right? Plus or minus 2i over 2. So divide them with 1 plus or minus 1i. And that's the answer. So right now, whenever you do a question on quadratic formula, you can always find a solution. Okay. If it's a square root of a negative number, you can write it as a complex number. So what about 2x squared minus x? So let's do this. So a is 2, b is negative 6, c is 17. So x is equal to negative of negative 6 will be negative of negative 6, negative b plus and minus b squared, negative 6 all square, minus 4a to 17, right? Put in the calculator, of course, divide by 4. So negative of negative 6 is 6, plus and minus, what do we have? Is 36 minus 4 times 2 times 17. So it's negative 100 because 8 times 17 is 136, and so this is negative 100. So it's kind of like a perfect square, over 4. But it's negative, so we write it as 6 plus or minus square 10i, right? You do the square root of 100, become 10 divided by 4. So split 3 over 2. And then you simplify this plus or minus 5 over 2i. Okay, so you can simplify it until the end. So that is the use of complex number. Oh, that's on. That's all for 3.1. So you would run into a complex number when you solve quadratic equation, when you try to do a square root of a negative number, and you would write it as I.